Okay, good evening, guys. Am I audible?
Sir, yes, sir, audible, sir.
Okay, thank you. Okay, guys. Today let us discuss about actuators. In previous classes, we discussed about sensors, various sensors which is used in the automotive vehicles, and the working principle of the sensors. We have also seen with video examples. So the practical demonstration of the some of the sensors also are seen in videos, and we discussed the most of the sensors in the previous classes. Now let us enter into the actuators. Okay, before enter into the actuators, what is the actuators and where it is used, these actuators, because and what command we need to give to the actuators and how it is working. So these are all one of the simple questions of actuators. We need to understand it before enter into the topic, actuators. Okay, and I think you are very well known about these actuators and where it is used. I think you have a better idea about the actuators. So the actuators are an essential part of electronic control system in most of the passenger cars and all automotive vehicles or commercial vehicles. It is their job to convert the electrical signals. Okay, the job of the actuator is it is going to convert the electrical signals from the control unit. The control unit is here nothing but ECU. So this is going to send the signals. EC is going to send the electrical signals that through the control unit, electronic control unit or module. So that signal is going to be transmitted to the actuators. The actuator is going to working based on the commands. That means the electrical signals which is given by the electronic control unit or module. Based on that, the actuator is going to be working. So this is what the simple method of what is meant by actuators. And the actuator is nothing but just we are going to giving electrical signals through from the electronic control unit or module. So that signal is going to transmitted through some of the wire cables. So that is transmitted to the actuators. So the in ECU already we are having, as I said in earlier classes, we are having a microprocessor or controller. So that is having some of the data based on the R&D department of the automotive manufacturers. So they store the data. So based on that data, so the EC is going to tell to the sensors. The sensor is going to monitor everything. Depends upon the data what is going to be stored already. So whenever there is any variation or deviation in the data, so the sensor is going to be sensing that signal is going to be transmitted to the ECU. Then ECU again give some comments to the actuators, and actuator is going to be controlled everything. So this is one of the cyclic process. So this is what happening in the automotive vehicles, most of the automotive vehicles. Yeah, the environmental productions, you just to see the increasing awareness of the environment on the part of drivers accompanied by rises in fuel prices are placing over more stringent demands on modern vehicles with regard to low fuel consumption and low pollutant emissions. But this must not be at the expense of top performance and ride comfort. These requirements can only be met with powerful actuators so that are able to supply the necessary amount of fuel to the engine with absolute precision and accurately control fresh air supply to the exhaust gas recirculation in order to optimize performance and as well as pollution characteristics. So here the actuators are essential part of electronic control system in passenger cars and commercial vehicles. It is their job to convert the electrical signals from the control unit into an action. Most actuators are electric motors or electromagnetic valves or devices. So they just adjust flaps, for example, regulate the flow of fluids or actuate pumps to build up pressure. So that means in brake and steering system example. So we can able to use these kind of things in the braking and steering system. In the engine control systems, actuator is going to regulate the ideal speed, control air flaps for torque and power optimization, and meter fuel for optimum combustion. Okay, in convenience systems, so they are used to lock and unlock car doors, for examples, for the remote control of fuel filler flaps, boot lids, engine bonnets, and the storage compartments in our automotive vehicles. So these are all the major areas or roles the actuator is going to place. So because of our comments, based on the comments we are going to give, based on the comments given, the signal, electrical signal is going to receive in the actuators through the electronic control unit. Then immediately it will work based upon the electrical signals what it receives. So next is the safety. In recent years, more powerful actuators in all manner of different designs have made numerous safety and assistance function possible. So here the actuators are the means via which drivers are provided with assistance in critical situations. So thus helping to avoid accidents or moderate their severity. Okay, there are so many actuators manufacturers are there in our country. For example, Bosch. We can say the Bosch and Valio and Denso and Hella and Peerberg. Okay, these are all some of the companies. They are manufacturing the sensors and actuators for automotive vehicles. Okay, the actuators, apart from that, the actuators also are used for injecting the fuels, and it is also controls ignition and ABS modulators, etc. So that are operated by the outputs from the electronic control units or module. So the actuators normally rely on one of the two electrical devices for their operations. They are either operated by a solenoid or by an electrical motor. The solenoid operated actuators are normally controlled in one of two ways. One is the duty cycle method, where the solenoid is switched on for a percentage of the time available, for example, 20 or 80 percentage. Okay, this means that pulses of varying width can be used to provide the desired result. So, other method of the solenoid control is as pulse width modulation. So, it is shortly called as PWM. Here, the solenoid current is going to switch on and off at frequencies that change suit operating requirements. So here also, so we are using electrical motors, so that is used in actuators because the this kind of electrical motors and electromagnetic devices going to obey the electrical signals, which is come from the electronic control unit or module. Here in automotive vehicles, we are going to use mostly the commands obeyed devices, the electrical signals obeyed devices we are using. So like here we are using a stepper motor or reversible permanent magnet DC motors. So there are some of the devices we are going to use depends upon the signals which that will receive. And next is a stepper motor can be made to provide a small movements of valves by pulsing the current supply. And next is some stepper motors rotate 7.5 degree per step, so which means that the full rotation of the motor shaft takes 48 steps, because it will name itself, so we can know what is mean by stepper motor. So it will not work in a continuous manner, so it will rotate at step by step. So but that speed should be high, but the rotation will be step by step. For example, here 7.5 degree step it will rotate. A common form of stepper motor uses two sets of windings. So current in one set of winding drives the motor shaft forward, and when this is going to switch off and current is applied to the other set of windings, the motor shaft rotates in the reverse directions. Okay, for forward and reverse, so there is a separate windings we are using. So depends upon the rotations, some coils will get power supply and some coils will not get power supply. And so based on the rotation, whether it is a clockwise or anti-clockwise, so the coils power supply is going to be getting switched off. So this means that accurate control over the position of valve can be achieved because the control computer determines the valve positions by counting the number of pulses applied to the stepper motor windings.
We're going to talk about actuators.
So
There's
here there are some
probably
of
not a day
the
that goes
actuators you
by
can able to
where you
see here
don't
the,
use or
for example,
encounter an
for your better
actuator at
understanding,
home
So
or
here I
door.
am showing on video the door actuator motor.
In this video, we're going to explain the purpose of an actuator, discuss the two types of actuators, look at the three typical sources of energy required for an actuator to move something, observe the operation of an actuator used in a very common industrial control application. Okay, let's get started. At RealPars, we love helping you learn. So if you enjoyed this video as much as we enjoyed making it, click the like button, subscribe and click the bell, and you'll receive notifications of new RealPars videos. So you'll never miss another one. In very simple terms, an actuator is a device that makes something move or operate. Every one of us takes advantage of at least one actuator every day. When we go to the grocery store, the door opens automatically for us. An actuator makes the door open. We can move the car seat forward or backward before we drive away in our car. An actuator makes the seat move. An actuator can move something in a straight line, also referred to as linear. Also, an actuator can make something move in a circular motion, also referred to as rotary. We've talked about the movement of an actuator, but we haven't discussed how or what makes it move. An actuator receives a source of energy and uses it to move something. To put it another way, the actuator converts a source of energy into a physical mechanical motion. In this example, the butterfly valve is operated by turning the hand wheel connected to the rotary actuator. In industrial applications, the hand wheel could be replaced by one of three typical sources of energy, which can operate the rotary actuator. Electric actuators use some form of electric energy to operate. Hydraulic actuators use a variety of liquids as a source of energy. Pneumatic actuators are operated by compressed air. Typical actuators in the industry include electric motors, hydraulic motors, and pneumatic control valves. Let's look at a typical pneumatic actuator in action. The PLC analog output card produces a 4 to 20 milliamp current to move the valve from fully open to fully closed. The 4 to 20 milliamp current will be converted to pneumatic pressure, which becomes the source of energy to operate the actuator. Okay, let's review what we've discussed. An actuator is a device that makes something move or operate. An actuator can move something in a straight line, referred to as linear, or in a circular motion, referred to as rotary. An actuator receives a source of energy and uses it to move something. In other words, the actuator converts the source of energy into physical mechanical motion. That source of energy can be in three different forms: pneumatic, electric, and hydraulic. Typical actuators in the industry include pneumatic control valve, electric motor, and hydraulic motor. If you'd like to learn more about any of the topics covered in this video, head over to our website at realpars.com. We'd love to hear your suggestions for topics you want our team to cover. Also, be sure to download the RealPars app. When you download
Okay, guys. Next, I think you may understand. So, what is the purpose of using the actuators and where it is used, and how many actuators are available, and what are the various purposes of actuators which is used in the various places. I think you understand because of seeing that video, you have better understanding. I think. Next, so we can see the solenoid valves. So because the solenoid valves, I think you are having a clear understanding of that solenoid valve. So when you are going to see this, so this solenoid valve is mostly used in many of the places. So not only in automobile, so many of the places, so we are using a solenoid valve. So the solenoid valves are the most frequently used to control the elements in fluidics, as well as they are commonly used to shut off, release, dose, or distribute, or mix some fluids. So for that reasons, they are found in many application areas. These are all the purpose of using that solenoid valve. And the solenoid valves also convert electrical energy to mechanical energy, so which causes a magnetic response. The solenoid activates when an electrical current comes through the wire coil. So there are many different types of solenoid valves are available, though direct acting and pilot operator valves are their two main categories. I think you may have one doubt whether the solenoid valve is controlled by AC or DC. So this solenoids are the most important components. So that is used in solenoid valves to control the flow of fluids and gases. These solenoids are electromechanical devices that convert AC or DC electrical energy into linear motion. Okay, I think so. Why do you need a solenoid? Some common applications for solenoid include vehicle starters, winches, snow plows, and electrical motors. A primary advantages of a solenoid is their ability to use a low input to generate a larger output via the coil. Okay, this is the important purpose of using the solenoid valve. So here, so also we are going to control the fluid flow or fuel injections with help of this solenoid valve. Okay, the fuel injectors you can able to see here the nozzle and the solenoid windings is around of that nozzle. So the plunger is also there. So the plunger is going to be get smooth. So here you can able to see this is a coil, and this is electrical current is going to pass through here, and then this is air gap, and this is a movable steel element. So this is you can also call it as plunger, and here we will have some mechanical load, and this is a spring actuator solenoid valve, and this is the air gap. So here a fuel injector, a solenoid operated fuel injector is a solenoid operated valve. The valve opens or closes to permit or block fuel flow to the engine. The valve is attached to the movable element of the solenoid and is switched by the solenoid activation. So in this case, in the fuel injectors with no current flowing, the solenoid movable element is held down against the stop, covering the aperture or nozzle. Okay, when there is no current flowing, so it will be in off position. So there is no fuel is going to enter into the cylinder during the suction period in petrol engine. Okay, in fuel is thereby blocked by from flowing from the pressurized fuel chamber into the aperture. So when current is going to get flows through the solenoid coil, then the movable element is going to switch it upward. The aperture is exposed and fuel sprays through this aperture. So some amount of pressure. So the fuel flow rate through the nozzle constant is for a given regulated fuel pressure and nozzle geometry. So therefore, the quantity of fuel injected into the air stream is proportional to the time uh, valve is open. So when time valve is going to open, when current flow is going to be happen, so then only it will be open. Otherwise, it will be in a closed condition. So the control current that operates a fuel injector is pulsed on and off to deliver precise quantities of fuel. So this
What we
is one of
have
the some
here
of the
is an
example videos.
M380
So you just
Superstroke
understood how it
solenoid
is
from
working.
G+. By modifying the geometry of the pole piece and magnetic return path of a tubular solenoid, G+ engineers have produced a device which
This is how
develops
this will
useful
operate
force
and
over an
inject the
exceptionally long stroke,
fuels.
while displaying the
So I'm
characteristics of a
going to show you
proportional
some of
solenoid.
the practical videos of
That
your
means
better
it develops a
understanding. So when
force
you
that is
listen this,
proportional to the
when you
current
watch,
being
it's
applied,
definitely you will
as
understood
you
very
can see
much.
here on the multimeter. Because this solenoid has been loaded with a spring that has a rising rate force characteristic, as the current increases, the force developed by the solenoid increases, allowing the solenoid to move proportionally to the current being applied. Because it's moving at a controlled speed, the noise at the end of the displacement is barely perceptible, as you can see on the sound meter here. While there is a steady background noise, any noise from the solenoid itself is insignificant. Compare this to a standard tubular solenoid where the displacement impact causes a spike on the sound meter. This quality makes the superstroke solenoid useful in applications that require a reduction in audible noise. For example, in elevator doors, automatic doors, and locking devices that need to be silent, or in medical equipment in environments where patients are sensitive to noise. In some countries, controlling the noise created when performing seemingly simple tasks has become a regulatory requirement. You can find the data sheet and technical specifications, including charts detailing stroke burst force and stroke burst response time, on this and all of our actuators by clicking the
So
Products
these are all
tab
the
at our
different types
website,
of actuators of this G plus
www.gplus.biz.
products.
You'll also find on the chart
So
that
they
this
are also
particular
supplying some of
solenoid has
the
a life
actuators
expectancy of
to the
over 2
automotive
million
vehicles and some
cycles.
other applications.
By using many of the components of the tubular solenoid, the G Plus Superstroke solenoid becomes a very useful, cost-effective solution for applications that would typically require more expensive long-stroke actuators or proportional solenoid design. For
So this is a fuel on off. When fuel is going to get on, the power supply, the voltage is become very high. When there is no power supply, so the valve is going to be getting a off position. So there is no power. When there is no power supply, so valve will not move. When there is some power supply, the voltage is high. When it is going to get on, the fuel high amount of fuel will be entered into the cylinder during the suction stroke. So this is the signal which is received from the electronic control unit or module. And this signal, how this signal is going to be received at ACM or ECU. So because of the sensor which we are using. Next is so we can discuss about the EG or valve, exhaust gas recirculation. So the exhaust gas recirculation valve actuators. So in this exhaust gas recirculation valve actuators, so first of all you want to know what is mean by EGR. Okay. So this it is a purpose to recirculate the exhaust gases that have excited the engine back into the intake manifold so that they can be reburned. Okay. So in this case, the and this dilutes the amount of oxygen coming into the engine by replacing some of it with inert gases. So which reduces the NOx levels and temperatures of the mixer. So in the exhaust gas recirculation system is controlled by the exhaust gas recirculation control solenoid. So when the exhaust gas recirculation control solenoid is activated, a passage is opened up that allows exhaust gases into the intake manifold. So the exhaust gas recirculation solenoid is controlled by the engine computer. So that is an electronic control unit or module. Okay, and it will activator at very specific times in order to achieve the best performance, efficiency, and emissions from the engine. So the exhaust gas recirculation solenoid is one of the main components of EGR system. So and any problems, so with it can cause the system to not function, so which can be a major problem in states with strict emission regulations. So usually a problem with the EGR control solenoid will produce a few symptoms, so that can alert the driver of potential problems that should be serviced. So the engine performance issues, one of the first symptoms of possible problem with EGR controlled solenoid is engine performance issues. So if the EGR solenoid has any issues, so it can cause the finely tuned air fuel ratio to be thrown off, and this may result in a decreased power, acceleration, fuel economy, as well as an increase in emissions. Okay, next is engine pings or knocks. The another symptom of a potential problem with the EGR control solenoid is engine ping or knock. If the EGR solenoid fails, it can disable the EGR system from the recirculating exhaust gases. For certain engines, this can cause a large increase in cylinder and exhaust gas temperatures. So this is excessively high cylinder temperatures can cause engine ping and knock, and which can lead to serious engine damage if left unattended. So this is some of the reasons. And so in this case, the vacuum that operates the diaphragm is supplied by the intake manifold, and that is controlled by a solenoid operated valve. So this solenoid valve is controlled by the output of the control system. So this solenoid will operate essentially the same as that explained in the discussion on fuel injectors. So whenever the solenoid is going to get energized, whenever there is a uh, power supplies, so whenever the is going to flows, so the easier valve is going to get opened because it is energized. So when easier valve is opened by the applied vacuum, so this will be moved in a upward directions. Then exhaust gases will be enters and it will enter into the inlet manifold. So it will increases the oxygen content to the cylinder during the suction stroke. So the amount of valve opening is determined by the average pressure on the vacuum inside of the diaphragm. So this pressure is regulated by pulsing the solenoid with a variable duty cycle electrical control current. So the duty cycle of this pulsing current controls average pressure in the chamber. So that will affect the diaphragm deflection. So thereby regulating the amount of electronic gas recirculations we can achieve it.
Exhaust gas recirculation, EGR for short, is an important
So
pollutant
you just
reduction
watch this
method
video,
in
so
petrol and
definitely you
diesel
will be
engines.
a very good understanding of the
Here
exhaust
we
gas
can see its
recirculations,
basic
how it
structure.
is recirculated to
Exhaust
the
gas is
cylinder.
taken directly after the cylinders.
So without
Then,
skipping anything,
the
so you just
EGR
see this
valve
video, so you
regulates
will
the
be
subsequent
understanding
mixing
very
of
good
the
manner.
exhaust gas with the intake air. This means that less oxygen reaches the cylinder. Less oxygen means a lower combustion temperature. This way, nitrogen oxide quantities can be reduced by up to 70%. As the higher the temperature, the more harmful nitrogen oxides are produced. In petrol engines, this can also reduce carbon dioxide emissions and fuel consumption. A key component of exhaust gas recirculation is the EGR valve. It meters the quantity of exhaust gas that is returned. EGR valves come in various designs and models, pneumatic or electrical, for petrol or diesel applications, or with connections for cooling. Regulating throttles are used in the intake air system in diesel vehicles. They generate the pressure difference required between the exhaust gas side and intake side to achieve the necessary high exhaust gas recirculation rates. Air mass sensors are required in diesel engines to regulate the exhaust gas recirculation, for example. With their help, the mass of the recirculated exhaust gas is calculated indirectly using the reduction of intake air. Since simple exhaust gas recirculation has no longer been sufficient to fulfill emission standards for some time, EGR coolers are used. Cooled exhaust gas reduces the peak combustion temperature even further. This again significantly reduces the amount of nitrogen oxides. Just like all components in the EGR system, EGR coolers are exposed to the extreme conditions of the aggressive exhaust gas condensate. They must therefore be manufactured from highly corrosion and temperature resistant materials. Many of today's EGR coolers feature an electrical or pneumatic bypass flap. They allow the exhaust gases to be directed past the EGR cooler in the warm-up phase to quickly bring the engine and catalytic converter to operating temperature. This also reduces noise generation, the so-called diesel knock, and the raw emission of hydrocarbons in the warm-up phase. Bypassing is also possible if high exhaust gas temperatures are required, for example in the recovery of the diesel particulate filter. The previous high-pressure exhaust gas recirculation system is no longer sufficient for meeting the limit values as of Euro 6 and Tier 2. An additional low-pressure EGR system is required. With this system, the exhaust gas is taken after the particulate filter on the low-pressure side and added again before the turbocharger compressor. An exhaust gas flap provides the exhaust gas back pressure required for this. Pierburg is a significant contributor to the current state of the art. The first EGR systems were used in some petrol-driven vehicles as early as the 70s. In the 90s, this technology also began to be used in diesel vehicles.
You guys, I think you have better understanding of this solenoid valve operated actuators. I think rest of the things we will discuss